More similar triangles, we're looking for x here. So x over, so between no lines and two lines, if we look at it that way, no lines and two lines is this side here. That's 7.5. That's equal to, we have a 42 here. Over between no line and this x value, or this 18 down the bottom here, over 18. So 18x is equal to 42 by 7.5. X is equal to 42 by 7.5 over 18. X is equal to, see a way of working that out without the calculator, 17.5. And then we have y, so y, start with y, between 2 and x is 17 in the other triangle, and that's going to be equal to, we have our 42, and that's the same ratio as the last one, so that will be over 18 in the other triangle. So 18y is equal to 42 times 17, so y is equal to 42 times 17 over 18. And again, this doesn't work out evenly. 39 recurring sixes, y is equal to 39. I'll round it off to 0.67. In question 4, for each pair of triangles, identify the pairs of sides that would be corresponding if they were similar. And B, using your answers from our day, investigate if they are similar. So with nothing else to go on here, we'd have to compare the longest side, 16, with the longest side in the other triangle, 28. Is that equal to the middle side, or we'll use the shortest side, we have them all, 10 over 17.5. Are these two things equal? That would have to be equal to, we compare all three, I think here, 12 over 21. That works out to be 4 over 7. And I can see that the last one works out to be 4 over 7. 20 over 35 would also be 4 over 7. So yes, these triangles here, yes, they are similar. In this one, we have 75 over 82. Longest over longest, middle is 50 over, middle is 60. Is that equal to the shortest, which is 40 over the shortest, which is 60? Well, we can see here now 5 over 6 is not equal to 4 over 6. So these triangles are not similar. Nope. Okay, question 5. A building casts a shadow of length 2.1 meters. So there's the shadow there. We could create a triangle if we wanted. At the same time, a 1 meter high pole casts a shadow of 0.25 meters. How tall is the building? We don't have any other diagram here. So we have a building casts a shadow of length 2.1 meters. So I have my building. Let's scrub that because actually we're looking at the height of the building here. I have my building and my 2.1. And I've got my 1 meter flagpole. 1 meter tall flagpole, 0.25. And we can see the right angles are here. So we want the height of the building x. X over 1 is equal to 2.1 over 0.25. 0.25x is equal to 2.1. So x is equal to 2.1 divided by 2.1 divided by 0.25, which is equal to, so we're multiplying by 4, 8.4 meters. That's the height of the building. Hope you're seeing some similarities between the questions. We'll do 6, and then we'll do 7, 8, and 9 in the next video. So 6. A student is 1.72 meters tall and has a shadow that's 2.5 meters long. So let's do the question. Here's my student, and here's my shadow. The shadow is along the ground, 2.5. A nearby tree. Here's my tree. The tree is the tree's shadow is 10.5, and we're looking for diagrams to represent the information which we have, and we're looking for the height of the tree, which is x. If you wanted to put some sort of tree diagram to represent the tree, you could. So we're looking for x. 1.72 is the equivalent side. We have 10.5. We have to use that. 2.5 is the equivalent. So 2.5x equals 10.5 by 1.72. So if I divide that by my 2.5, I'll get x to be 7.224 meters. We're not asked to round. I'll leave it at 7.224. We could have this diagram as well as one diagram. If you wanted to put the person inside the triangle, we could show the same angle and the right angle for similar triangles if you wanted. No need though.